In this video, we're going to look at how to graph a quadratic using the general quadratic formula. If you have a quadratic in trinomial form, you can find the axis intercepts by using our quadratic formula, which you should remember is minus b plus or minus the square root of b squared minus 4ac over 2a. That gives us our two x-intercepts by following this formula. The other things that this formula can help us do is, first of all, find the axis of symmetry, which is the x-coordinate of our turning point, and that comes from this part here of our quadratic formula. The minus b over 2a gives us our axis of symmetry. This part here is what we call the discriminant, and that's the bit that's under the square root sign. And that discriminant helps us to work out how many solutions or how many x-intercepts our graph has. Let's have a look at that in a little bit more detail. Our discriminant, b squared minus 4ac, tells us the intercepts. Now you should remember that a parabola can have two x-intercepts, it can have one x-intercept, and it can have no x-intercepts if our graph is up above the y-axis, above the x-axis, or down here below the x-axis. To help us work out which one of these parabolas we have, our discriminant can do that. If our discriminant is bigger than 0, in that b squared minus 4ac is bigger than 0, we know we're going to have two solutions to our graph, two x-intercepts. If our discriminant equals 0, we're just going to have one point on the x-axis where the graph touches, which will be the turning point. And if our discriminant is less than 0, then we have no solutions, which means we have no x-intercepts at all. Let's have a look at an example of that. If we have this trinomial here, 3x squared minus 6x plus 5, determine the number of x-intercepts. It's not asking you to find them, it's just asking you for the number. If you see that, your thinking should be leading you into finding the discriminant. In here, in this trinomial, our a is the coefficient of the squared term, our b is the coefficient of the x term, and our c is the constant term, which in this case is 5. So these values here go into our discriminant. So the discriminant is b squared. Now that's minus 6 squared minus 4 times a times c. Minus 6 squared is 36. Minus 4 threes are 12, 12 fives are 60. Now you can go and work this out. 36 take 60 is minus 24. You don't actually have to come up with a solution because you're just interested in whether our discriminant is less than 0, greater than 0, or equal to 0. From at this point here, you know that it's going to be a negative. You really don't care what value it is, you know that it's negative. So since our discriminant is less than 0, there are no solutions, which means our graph will be sitting up above the x-axis. I'll just make some more room here. Okay. Part B in this question is asking us to find the y-intercept. So this is part A. Part B, find the y-intercept. The y-intercept, you make x equals 0. So y is going to be 5. And x is 0, y is 5. Part C, use x equals minus b over 2a to determine the turning point. This here will give us our axis of symmetry. I'm just going to insert a new page to give me room here. So we had y equals 3x squared minus 6x plus 5. I know my axis of symmetry x equals minus b over 2a. So x is minus 6 over 2a. So x is 6 over 6. My axis of symmetry is 1. Now I need to substitute x equals 1 into y to find the y value of that coordinate. So y is 3x squared minus 6x plus 5. 1 squared is 1, 3 times 1 is 3. Take 6 plus 5. 3 take 6 is minus 3 plus 5 is 2. So my turning point is 1, 2.